Topic 6, flashcards, quadrilaterals, and polygons. The first thing you need to know is what is a polygon. A polygon is a two-dimensional figure with at least 3 sides, and the sides have to be straight. There's no curves on these, and they have to create angles. So here's some examples. A circle or something that is circular would not count as a polygon because of the curves. There has to be straight sides. Properties of a parallelogram. The parallelogram is a 4-sided figure, and opposite sides will be congruent, and opposite sides will be parallel, hence the name. Opposite angles are congruent. Consecutive angles are supplementary, and then diagonals bisect each other. So although it's not listed here, it is visualized with those arrowheads that the opposite sides are parallel. Okay, so opposite sides are parallel and congruent. The diagonals bisect each other, but don't necessarily have to be the same. So from here, DE to BE, those will be the same, but they don't have to be the same as the other diagonals. The diagonals just get cut in half. And then consecutive angles, that's one right after each other. So like this big angle A and this big angle B, the whole thing, those would add up to 180 together. Properties of a rectangle. Everyone thinks they know what a rectangle is, and you're probably right, but did you know a rectangle is a parallelogram? So if you forget what those properties are, you can link this and it will just take you back. Here's the properties of a parallelogram. Okay, so let's go back here. The parallelogram, first of all, so all those rules apply. Opposite sides are congruent, opposite sides are parallel, consecutive angles, everything we just talked about in parallelogram. But each interior angle is also 90 degrees. So every one of these angles, A, B, C, D, are each 90, which means they add up to 360. And the diagonals in this case would be exactly the same. Properties of a rhombus. When you're a little kid, you probably don't learn the shape rhombus. You probably have heard of a diamond. In geometry, we don't count that. It's not a diamond shape, it's a rhombus. A rhombus is a parallelogram, so you can click and figure out what the properties of a parallelogram are, but all 4 sides are congruent. So not just opposite sides, all 4 sides are congruent. The diagonals, when they come together, they don't just bisect each other, but they are perpendicular. So they intersect at that 90-degree angle. And then the diagonals bisect the angles of the rhombus. So if I have a diagonal here, it would cut this angle in half. And the diagonal here would cut these angles in half. So they cut each of the opposite angles in half, or they bisect those angles. Properties of a square. I love a square because this is what's so crazy about a square. It's a parallelogram. All those rules apply. It's a rhombus. All those rules apply. And it's a rectangle. All those rules apply. And again, if you don't remember what they are, go back and look. So rectangles actually fits into all 3 of those categories. Trapezoid. It's still a 4-sided figure, but it's not a parallelogram. It has exactly 2 sides that are parallel, or 1 pair. So if you look, these 2 sides are parallel. Those are called bases. They're both called bases. And then these other 2 sides, they're just called sides. They may or may not be the same, but the 2 bases have to be parallel. Here's the example. Isosceles trapezoids, they will have the 2 non-parallel sides. Those sides will be congruent. So the non-parallel sides are congruent. The lower base angles down here will be congruent. The upper base angles will be congruent. And any lower base angle, so either one of these 2, if you put together it with the measurement of one of these 2 angles, they'll add up to 180. So they're supplementary. A bottom angle and a top angle only on an isosceles trapezoid. They will be supplementary. And then if it's an isosceles isosceles trapezoid, the diagonals will also be congruent. A kite. Also a 4-sided figure. That's what we're really hitting hard on in 4-sided figures at the beginning here. Properties of a kite are that 2 pairs of consecutive sides are congruent. So these 2 sides are congruent, these 2 sides are congruent. So they have to be in a row, but obviously, as you can see, the red and the blue, those are not congruent. So you usually have a short side and a longer side, and these 2 sides are congruent, those 2. The diagonals are perpendicular. They come together at a 90-degree angle. And then these are called the non-vertex angles. This really long diagonal, that creates the vertex angles. So these where it says angle A and angle A, those two angles will be congruent, the non-vertex angles. Okay, in all these quadrilaterals that we talked about, they all kind of fit together. So I have this visual, quadrilaterals. All of these are quadrilaterals. And yes, I know it's kind of grainy. Parallelograms have rhombi as the plural for rhombus. So rhombus, rectangles, and the square fits in between both of those. A trapezoid, you can have trapezoids, but you can have an isosceles trapezoid within that category. And kites are just their own thing. They do their own thing. They're still a quadrilateral, meaning four-sided figure, four-sided polygon, but they don't really fit into a trapezoid or a parallelogram. Interior versus exterior angles. We've talked about interior and exterior before, so I'm hoping the angle part is doable. Interior is on the inside. Exterior is on the outside of the polygon, but notice only this blue part. It's when one side is extended and the angle created between the side of the shape and that line extended. So it's just that. It's not this whole exterior angle. It's just that little piece. So outside of the polygon, the angle between any side of the shape and the line extended. So that is the exterior angle. All those blue ones are. Some of the interior angles of a polygon, there is a formula that will tell you how many degrees, total degrees, are in a polygon. And so let's go over that. To find the total interior angles, find the number of triangles. And to do that, you just say n minus 2 and multiply by 180. So triangles all have 180 degrees. So basically you're figuring out how many triangles are in every polygon. And when we go over the lesson, I go over this in detail about each of the diagonals and how many triangles are made, but it's number of triangles times 180. But so that you don't have to go and count triangles, it's just always n minus 2. N is the number of sides. So the number of sides minus 2, and then multiply by 180. If I was trying to find one interior angle of a polygon, and these have to be regular polygons, meaning all the angles are the same. So if I wanted to find one, you would take that formula, n minus 2 times 180, and then just divide it by however many angles you have or sides you have. So it's the same thing as the previous slide, but then divide by n. Some of the exterior. So I explained this a little bit more in depth in the lessons, but if you had all the exterior angles and you added them all up, you would basically connect all those little pieces of the exterior angles, and it would be 360 every time, no matter what type of polygon you would have. All these colored angles, that just makes a circle. It's 360 degrees every time. So if you wanted to find one of those and they were all the same, you would take 360 and divide it by n just to find one. Midsegment. So long time ago, we learned about midpoint. So here's a midsegment. It's actually really similar, and it uses midpoints. So if I have a trapezoid, and it does not have to be an isosceles trapezoid, but if I had a trapezoid and I had the midpoint of this segment and the midpoint of this segment, and I put a segment to connect the two midpoints, that is called the midsegment. Diagonals. Diagonals in any polygon are connecting non-adjacent vertices, so the vertex. So from C, I can't go from C to A because that's adjacent. That's like one right after the other. So you go to non-adjacent, not right next to each other. In this hexagon, I could go from E to A because those are not adjacent. I could go from E to C. Those are not adjacent. So that would work as well. Consecutive means one right after the other. So if I was talking about consecutive angles, it's the angle and then the immediate angle right after it. They're usually considered next to, or they share that same segment. But angle Q and S, those would not be consecutive because there's another angle in between it. In fact, those are called opposite angles. Okay, and like always, I have left you some blank slides where you can add some more of these to your list of flashcards. I hope that helps.